Hello, I'm Mazia Shreem VS. This video is about linked list data structure and its implementation using pointers in C. So what is linked list? Linked list is a collection of elements called nodes. What is node? Node contains two fields. First one is data and the other one is link. Data contains the actual data and link points to the address of the next node. And here we are using two terms, head and tail. Head points to the first node of linked list and the tail is the last node of linked list. If the linked list is empty, then the value of the head points to null and the tail node always points to the null, which means it is the last node. Here is an example. The first node is head node, which contains two parts, data and link part. Data part contains the value of 12 and the link part contains the address of the second node, which means second node is in the location of 2000, then the link part contains 2000, which means the address of second node. And the second node has two parts, data part and link part. Data part contains the value of 20 and the second part, link part, contains the address of the third node. And here is the third node, which is the last node. So it has also two parts. First one is data part. Data part contains the value of 28 and the second part, link or pointer part, which is the null, which points to null because it is the tail of linked list. We are going to the definition of linked list. A linked list is an ordered collection of finite homogeneous data elements called nodes where the linear order is maintained by means of links or pointers. So here the data are finite and homogeneous and it is an ordered collection. What is homogeneous? Homogeneous means if a node consists of only one data part and it contains integer value, then all the nodes contains the integer value. Okay, so the linked list can be classified into three major groups. First one is a single linked list and the second one is double linked list. Third one is circular linked list. In this video, we focus only on the single linked list. So we are moving to the implementation of linked list. In C, we can create a node using a self-referential structure. So what is self-referential structure? Self-referential structure is a structure which contains a pointer to a structure of same type. Here is an example. Struct example. We are creating a structure named example. Struct is a keyword, example is its name, structure's name, and here two data are here, A and B. First one is integer and the second one is float, and the third one is link, which points to the structure itself. Struct example star self, which points to the pointer, points to the structure itself. So we are using a self-referential structure to create a node. We know that a node contains data and a pointer, which is two different things. We know that when we have to combine two different things, we are using structure. So here an example for a creation of node, struct node. Structure is a keyword and node is a name. Here a data part and a link part is there. The data is in integer. We can use any data type, integer, float, any other data type. And struct node start next, which is a self-referential structure which points to the next node. Okay, each struct node has a data item and a pointer which point to the another struct node. Here is the general representation of a single linked list. The struct node, struct is a keyword and node is a name, and data type, data 1, data 2, we can use any data type, and the last one is link to the next node. Struct node star link to the next node. Here we are going to declare the head pointer and make it as null. What is head pointer? Head pointer is the first node. So we are creating declare a head pointer. So we are using two header files, hash include stdio.h and hash include stdlib.h. We are using stdlib.h because we are using malloc function here for allocating memory. So that's why we are using stdlib.h. And so we are creating a node, struct node, and it has an integer value and a pointer, struct node star link which points to the next node. In main function, we need to create a pointer which is head and initialize it with a null value. Then memory will allocate to this node. Memory will allocate to this node using malloc function. In the bracket of malloc function, we write how many size we want. How many size we want? The size of the node. So malloc function, in the bracket we write the size of the node, and that value will store in head. So we are going to assign the value to this node. Head arrow operator data equal to 45 means we are assigning 45 value of 45 to the data part in the node, and head arrow operator link equal to null means we are assigning the pointer part in the node to the null value, which means the node contains two parts, a data part and a link part, and data part contains the 45 and link part contains null value. If we want to print the data of the first node, then we can simply write the printf %t comma head arrow operator data, then the output will be 45. We can simply display the output like this or data like this. Okay, now we are going to create these nodes. The first one is 1000 location node, which allocated in 1000 location. 45 is the data part and 2000 is second node's location. Okay, address of the next node, which contains the address of next node, which means the second node's location 2000. And the second node contains the data 98 and the third node's address location, and third node contains the data 3 and null value. Null value because it is a tail function, tail node. And head pointer contains the first node's address, which means the 1000. So till now we have created first node 45. The data part is 45 and the address is assigned to null value, and we need to create the second node, and first node's address location will assign to the second node's location. Okay, that's what we are going to look for. Okay, so now we have created a head pointer, and which stores the 1000 value now. Okay, and the head pointer data equal to 45 and the head pointer link is assigned to null now. Then we have to create the next node. We are using the other pointer which is the temp, and the struct node start temp is equal to malloc. We are allocating memory for the same, and temp data equal to 98 and temp link equal to null. Now the second node is created and the data is assigned with the data is now 98 and the link is now null. Okay, we have to now we have to change the head arrow operator link to the second node's location, which is the temp, which is stored in temp. Okay, the second node's location is stored in temp, and we need to change the head arrow operator link equal to null to head arrow operator link equal to temp. Now the first node's link part is contain the second node's location, okay, which is 2000. Now understand? Okay, and we also need to create the third one, and we are using temp2 pointer here. Struct node temp2 equal to, we are allocating memory for the same, and assign the data value, and link assign link with the null value, and we are changing the temp, the second node's link equal to what? The second node's link equal to temp2, the third node's address. Okay, third node's address is where is the third node's address? In temp2. Okay, so temp arrow operator link equal to temp2. Now the second node's address contains the third node's address, and the first node's address contains in the second node's address. Okay, the second node's address. So we are created like this. Head pointer contains the location of first node, which is the 1000, and we created a head pointer and store the location 1000 to the head pointer, and we are assigning the data part to the 45, and we are created temp pointer, and we assign the second node's location to the temp pointer, and we change the head pointer's link to the temp. Okay, now temp the location of second nodes is in the head pointer link equal to temp. Okay, then we created what? Temp2, and assign the temp2 value to the address location of temp, which means the temp arrow operator link equal to temp2. Okay, and then temp2's address location assigned to null. That's all.